The sound lasted 6 seconds. The psychological effect lasted a lifetime. RAF Flight Lieutenant David Harper sat in the cockpit of a captured Junkers Ju-87 Stuka at the Royal Aircraft Establishment in Farnborough, his hand hovering over a lever that wasn't connected to weapons, wasn't connected to engine controls, wasn't connected to anything that would help him fly or fight. It was connected only to a siren, just a siren. His orders were simple: activate it during a dive, measure the acoustic properties, file a technical report. But what he was really being asked to do was weaponize terror to understand how the Germans had turned physics and psychology into something that made grown men abandon their posts before a single bomb fell. In 90 seconds, he would discover that some weapons don't kill you. They break something deeper. This is the story of Allied engineers testing a captured Stuka dive bomber in 1943. But it's really about the moment when military analysts had to confront an uncomfortable truth: that fear could be engineered as precisely as any bomb, that the human nervous system could be exploited like a tactical weakness, that the Germans hadn't just built an aircraft, but had built a psychological weapon that violated every assumption about what warfare was supposed to be, and what it reveals about the gap between the war we think we fight with reason and courage, and the war that's actually fought in the space between our neurons, where sound becomes panic and panic becomes collapse. Summer 1943, Farnborough, England. The Stuka sitting on the tarmac had been captured in North Africa, forced down by engine failure, its pilot and gunner taken prisoner before they could destroy it. For 2 years, this aircraft and others like it had been the symbol of German air supremacy, the icon of blitzkrieg, the image that appeared in every newsreel of falling France and burning Poland. The gull-winged silhouette was famous, but it was the sound, always the sound, that people remembered. Soldiers who had faced Stuka attacks described it the same way. It wasn't like other aircraft noise. It didn't sound mechanical or neutral. It sounded alive, malevolent, personal, like something designed specifically to find the fear center of your brain and hammer it until you broke. Allied intelligence had known for years that the Stuka was, objectively speaking, not a particularly impressive aircraft. It was slow, maximum speed, barely over 380 kilometers per hour. It was vulnerable, lacking the armor and defensive armament to survive against modern fighters. It had limited range, poor high-altitude performance, and handling characteristics that made it a liability in any kind of contested airspace. British pilots called it a flying target. American analysts noted it would be obsolete by any reasonable measure, and yet, and this was the part that haunted Allied commanders, it kept working. Not mechanically, the machinery was unremarkable, but psychologically it kept working. Troops who had faced Stukas described a kind of paralysis, a shutdown of rational thought, an overwhelming compulsion to flee, even when tactical doctrine said to hold position and return fire. The aircraft shouldn't have been effective. The numbers said it shouldn't work, but the screaming men being evacuated for psychological collapse said otherwise. To understand what Harper was about to experience, you first need to understand what Allied military doctrine believed about fear in 1943. They believed fear was a weakness to be overcome through discipline and training. They believed that rational soldiers, properly prepared, would respond to threats with tactical countermeasures rather than panic. They believed that morale was a function of leadership, unit cohesion, and confidence in equipment. Fear was treated as a failure of character, something that happened to insufficient men, something that could be trained out or commanded away. This wasn't unique to the Allies. Every military in history had operated on these assumptions. That courage was a choice, and fear was a choice, and the difference between victory and defeat was making the right choice under pressure. The Stuka was about to reveal that everything in that paragraph was, if not wrong, then dangerously incomplete. Because the Germans hadn't approached fear as a moral failure to be overcome. They'd approached it as a biological response to be triggered. They'd studied how the human nervous system processes threat. They'd measured the frequencies that cause maximum psychological distress. They'd engineered a sound that didn't just announce an attack, but that reached into the most primitive part of the human brain, the part that evolved millions of years before concepts like duty or courage or tactical doctrine, and activated threat responses that conscious thought couldn't override. They'd turned psychology into artillery. Harper climbed into the Stuka's cockpit, surrounded by engineers carrying acoustic measurement equipment, frequency analyzers, decibel meters, instruments designed to turn something as subjective as terror into objective data. The goal was clinical: measure the sound, understand the mechanism, develop countermeasures or psychological preparation techniques, strip away the mythology, and examine the physics. They were treating it like any other technical problem, which is exactly how engineers are trained to think. Reduce complexity to measurable variables, find the mechanism, solve the puzzle. What none of them had quite articulated was the unsettling question underneath the technical brief: what does it mean that fear can be engineered? What does it say about human agency, about courage, about the stories we tell ourselves about why some men break and others don't, if it turns out that the right frequency at the right volume can override all of that? The aircraft itself was a study in contradictions. Up close, without the mythology, it looked almost ungainly. The gull wings gave it a strange, predatory silhouette, but they were purely functional, designed to keep the fixed landing gear short and strong. The cockpit was cramped, visibility was poor compared to fighters, the controls felt heavy. This was not a machine built for elegance. It was built for a specific job: carry one large bomb or several small ones to a precise point, drop them vertically from a steep dive, pull out, survive long enough to repeat. Every design choice sacrificed something: speed for bomb load, maneuverability for stability in the dive, pilot comfort for structural strength, and bolted to the landing gear, almost as an afterthought, except it clearly wasn't an afterthought, were the Jericho trumpets. Small wind-driven sirens, mechanically simple, just air-driven propellers connected to acoustic chambers, no electrical system, no complexity, just physics and psychology welded together. Harper had read the reports from front-line units, the accounts that intelligence officers had collected and tried to analyze. A British sergeant in France, 1940, describing his first Stuka attack: the sound wasn't loud at first, it built, it got into your head, and even though you could see they were still far away, your body was screaming at you to run. Men who'd been steady under artillery fire just got up and ran, not because of what the Stukas did, but because of what they sounded like they were about to do. An American observer with French forces: the tactical impact was negligible, most bombs missed, the actual casualties were light, but entire positions were abandoned. Not because they were destroyed, but because the men couldn't stand the sound. What made these reports disturbing wasn't that men experienced fear. Fear under attack is normal, universal, expected, but that the fear seemed disproportionate to the actual threat, that it seemed to bypass the rational assessment that soldiers are trained to make, that it seemed to reduce experienced troops to something primal and uncontrollable. The engineering team finished installing their measurement equipment. Microphones positioned at various distances, accelerometers to measure vibration, even electrodes that would be attached to Harper's hands to measure galvanic skin response, the electrical conductivity of skin that changes with stress and arousal. They were going to measure everything. The plan was methodical. Harper would take off, climb to 3,000 meters, enter a dive at the standard Stuka attack angle of 60 to 90 degrees, activate the sirens, maintain the dive to 500 meters, pull out, land, debrief. The engineers would collect their data. The psychologists observing would note his responses. The acoustics team would analyze the frequency spectrum. Science would explain terror, and explanation would rob it of power. That was the theory. But sitting in that cockpit reading the German instruments with their unfamiliar markings, Harper felt something he hadn't articulated to the briefing team. He felt like he was about to do something transgressive. Not dangerous. The flight itself was routine, the aircraft was airworthy. He was an experienced test pilot, but transgressive in a different way. He was about to weaponize himself against himself, to activate a system designed to break men like him, to voluntarily subject himself to something engineered to override his training and discipline and rational thought. The engineers saw an acoustic experiment. Harper saw something closer to a philosophical question. When you know a stimulus is designed to manipulate you, does that knowledge protect you? Or does the manipulation work anyway, operating on levels below conscious awareness, below choice, below the self that thinks it's in control? He advanced the throttle. The Junkers Jumo engine coughed to life with its characteristic rough idle 1400 horsepower driving a 3-bladed propeller, pulling the ungainly airframe down the runway. Takeoff was surprisingly gentle. The Stuka had been designed for operation from rough forward airfields. It didn't need much runway, didn't need high speed. It just climbed away steadily, heavily, like something that knew exactly what it was built to do and did it without grace or apology. Harper circled, gaining altitude. Watching the altimeter crawl through 1,000 meters, 2,000 meters, 2,500 meters. Below him, the English countryside looked peaceful. Wrong war, wrong country for this machine. The Stuka belonged over burning cities and collapsing armies, over the landscapes of 1940 where everything was moving wrong, where the old rules were being rewritten in real time, where this obsolete dive bomber had somehow become the symbol of unstoppable momentum. At 3,000 meters, he leveled off and took a breath. The engineers had emphasized that he should activate the sirens early in the dive. That's what German pilots did. The sound was meant to build as the aircraft accelerated and the dive steepened. He rolled the Stuka onto its back, a maneuver that felt unnatural in something so heavy, and pulled through into a near-vertical dive. The aircraft responded exactly as designed, rock steady, no tendency to spin or deviate, just a stable platform accelerating downward. The altimeter unwound, 2,800 meters, 2,600 meters, airspeed building. This was the moment. His hand found the siren activation lever. The engineers were recording. The psychologists were watching. Below him, empty fields that didn't care. He pulled the lever. For 1 second, nothing. Then the sound began, quiet at first, almost curious, a rising tone that grew and kept growing, building in volume and intensity, a shrieking mechanical wail that seemed to come from everywhere, and inside his own skull simultaneously. Harper's hands tightened involuntarily on the controls. His breathing quickened without his permission. The sound wasn't just loud, volume didn't capture it. It was piercing, overwhelming, invasive, a frequency that seemed to resonate in his chest and gut and teeth, that made his whole body feel like it was vibrating in sympathy, with something designed to announce incoming death. He'd expected noise. This wasn't noise. This was weaponized acoustics. This was physics deployed against psychology. This was a tone seemingly calculated to bypass every rational layer and speak directly to the part of his nervous system that just wanted to escape, to flee, to make the sound stop by any means necessary. The altimeter continued unwinding. 2,200 meters, 2,000 meters. The dive was stable, but Harper found himself fighting an almost overwhelming urge to pull out early, to end the dive, to make the sound stop. He knew intellectually that he was safe, that the aircraft was under control, that this was a test flight over friendly territory with no actual danger. The knowledge made no difference. His body was responding to the sound as if it signaled genuine imminent threat. Adrenaline dumped into his bloodstream. His peripheral vision narrowed, his heart rate spiked. Every instinct screamed that he was in danger, that he needed to act, to do something, anything, to change the situation. And he was alone in the cockpit, no one shooting at him, no actual enemy, just a siren and the way that siren rewired his nervous system in real time. This is the part of the story where we need to slow down and understand something about human psychology, about the layers of processing that happen between stimulus and response. When you perceive a threat, the signal doesn't go first to your prefrontal cortex where rational thought happens. It goes to the amygdala, the brain's threat detection center, which evolved hundreds of millions of years ago and operates on simple rules. Fast detection, immediate response, bias toward false positives because the cost of missing a real threat is death. The amygdala processes threat faster than conscious thought. It can trigger a full fight or flight response before you've consciously registered what the threat is. This is normally useful. It's why you can jump away from a snake before you've consciously identified it as a snake, why you can duck from a thrown object before you've calculated its trajectory. But it's also why the Stuka siren worked. The Germans had found frequencies, around 500 to 800 Hz in the peak intensity range, that human neurology seems to process as threat signals. Some researchers believe these frequencies overlap with primate alarm calls, with the sounds predators make, with acoustic patterns that our evolutionary history primed us to interpret as danger. True or not, the effect was measurable. The sound triggered threat responses below the level of conscious control. It didn't matter if you knew rationally that you were safe. Your amygdala didn't care about rational knowledge. It heard the sound, classified it as threat, and initiated a cascade of physiological changes: stress hormones, increased heart rate, tunnel vision, muscle tension, all the preparations for immediate physical action. And if you couldn't act if you were pinned down in a trench or a building with nowhere to run, those preparations had nowhere to go. They just built and built until something broke. Harper pulled out at 500 meters, the Stuka's recovery system working as designed, the controls heavy but responsive, the aircraft transitioning from screaming vertical death dive to level flight in one smooth motion that probably felt like salvation to anyone below. The siren wound down. The sudden silence felt almost physically shocking, like pressure releasing. Harper found his hands shaking on the controls. He leveled off, aimed for the airfield, forced his breathing to slow, and tried to process what had just happened. He'd been prepared for noise. He'd expected it to be unpleasant. What he hadn't expected was how profoundly the sound had affected him, how completely it had overridden his training and experience, how viscerally his body had responded to something he knew was just an acoustic effect, with no actual danger attached. He landed and shut down the engine. The engineering team approached with their instruments and clipboards and measuring equipment, eager to collect data, to analyze waveforms and frequency spectra and acoustic propagation patterns. Harper climbed out of the cockpit and stood on the tarmac for a moment, not quite ready to debrief, trying to find words for something that felt like it existed beyond words. One of the psychologists noticed his hands were still shaking. "That bad?" the psychologist asked. Harper looked at him. "It's not that it's loud," he said slowly. "It's that it gets into you. It's like it finds every fear reflex you have and pulls all of them at once, and knowing it's designed to do that doesn't help. That's the worst part. Knowing doesn't protect you." Over the following weeks, the Allied engineering team conducted exhaustive analysis. They measured everything. The Jericho trumpets produced sound in the range of 80 to 100 decibels during a dive, increasing as airspeed increased, reaching peak intensity around 100 decibels as the Stuka accelerated through 500 kilometers per hour. The primary frequencies were concentrated in the 500 to 800 Hz range, with harmonics extending up and down the spectrum. Acoustic measurements showed the sound was directional, loudest below and in front of the diving aircraft, which meant it maximized psychological impact on the targets, while being somewhat less overwhelming for the pilot. They documented how the dive angle affected the siren's pitch, how airspeed modulated volume, how the recovery from the dive created a characteristic falling tone that became almost a signature. They turned terror into graphs and tables, but the data couldn't quite capture what Harper and other test pilots reported. British Flight Lieutenant Thomas Morrison, who flew the captured Stuka multiple times, each flight was the same. You know what's coming, you brace for it, and it still gets to you. It's not about volume, artillery is louder. It's something about the quality of the sound, the way it builds, the frequencies. It feels personal, like it's targeting you specifically. An American pilot brought in for comparative assessment. "We have dive bombers, I've flown Dauntlesses, but our aircraft just make engine noise. This is different. This is deliberate. Someone sat down and designed this sound to mess with your head, and they were good at it." The engineering analysis confirmed what Harper had experienced. The Stuka's sirens were operating in a frequency range that human hearing is particularly sensitive to, the range where we perceive sounds as loudest and most intrusive, the range that's difficult to ignore or tune out. The rising tone during the dive created a sense of increasing urgency and imminent impact. The high volume triggered automatic startle responses. The mechanical, inhuman quality of the sound prevented the kind of habituation you might develop to natural sounds. It was, the analysis concluded, an almost perfect acoustic weapon. Not perfect in killing, the Stuka's actual bombing accuracy was moderate, and its vulnerability to fighters was severe. But perfect in creating psychological impact disproportionate to actual damage. Allied intelligence began correlating this technical analysis with battlefield reports, trying to understand not just how the siren worked, but what effect it had actually had on combat effectiveness. The pattern was consistent across multiple theaters and armies. Units facing their first Stuka attack often broke regardless of other factors. Units that had faced Stukas multiple times developed some resilience, but never complete immunity. The psychological casualties, men evacuated for combat fatigue or breakdown, were disproportionately high in units that had been subjected to dive bombing with Sirens, compared to units that faced similar levels of conventional bombing. The sound, independent of the actual destruction, was degrading fighting effectiveness. French Army after-action reports from 1940 painted a devastating picture. Units that had held firm against German artillery and infantry attacks had abandoned positions when Stukas appeared. Not because the Stuka attacks were more destructive, artillery caused more casualties, but because the combination of sound and dive bombing created a kind of psychological pressure that conventional weapons didn't. A French officer's report, the men could endure the shells, they could endure the tanks. The Stukas were different. The sound made them feel hunted, targeted individually. Rational orders meant nothing against that fear. British reports from France and later North Africa showed similar patterns. American troops in North Africa initially suffered the same effects until doctrine and experience built some resistance. What made this particularly insidious was the gap between the mythology and the reality. The Stuka in 1943 was, objectively, a vulnerable aircraft. RAF Fighter Command had decimated Stuka formations during the Battle of Britain, forcing the Luftwaffe to withdraw them from operations over England. Any modern fighter could catch and kill a Stuka with relative ease. Allied air defenses, even ground-based anti-aircraft fire, could shoot them down at rates that made their use suicidal in contested airspace. The Germans knew this. They'd largely relegated Stukas to ground support roles on the Eastern Front, where Soviet air opposition was weaker, and to theaters where the Allies hadn't yet established air superiority. The aircraft itself was obsolete, outclassed, unsurvivable against competent opposition. But the fear remained. Even troops who had been briefed that Stukas were vulnerable, even troops who had seen Stukas shot down, even troops who rationally understood that their own air cover made Stuka attacks unlikely, those troops still responded with disproportionate fear when the siren sounded. The mythology had outlived the tactical reality. The psychological weapon continued working, even after the platform carrying it had become obsolete. This was the uncomfortable insight that Allied analysts were confronting. You could win the technical battle, achieve air superiority, make an enemy weapon system tactically non-viable, and still lose the psychological war because the human nervous system doesn't process threat through rational cost-benefit analysis. Harper flew the Stuka a dozen times over the following months as the testing program expanded. Each flight included siren activation. Each flight produced the same response. Intellectual knowledge that he was safe. Physiological response as if he were in danger. Inability to fully reconcile the two. He got better at managing it. Better at maintaining control while his body screamed at him to flee. But he never stopped responding. The adaptation was at the behavioral level. He learned to function despite the fear response, but he couldn't eliminate the response itself. This mirrored what battlefield reports showed. Experienced troops learned to hold position during Stuka attacks, learned to return fire, learned to function, but the internal experience of fear didn't diminish proportionally. They just got better at operating while terrified. The psychological team's analysis went deeper, trying to understand not just the immediate fear response, but the lasting effects. Soldiers who had been repeatedly subjected to Stuka attacks showed patterns consistent with what would later be understood as trauma responses, heightened startle reflexes, intrusive memories triggered by sounds even vaguely similar to the Jericho trumpets, sleep disturbances. Some men reported that years after their combat service, certain sounds, air raid sirens, aircraft engines, even machinery operating at similar frequencies, would trigger visceral fear responses identical to what they'd felt under actual attack. The Stuka hadn't just frightened them in the moment. It had altered their nervous systems in ways that persisted long after the threat was gone. This raised questions that military psychology in 1943 wasn't fully equipped to answer. If courage is a choice, what does it mean that a sound can override that choice? If discipline and training are supposed to prepare soldiers for combat stress, what does it mean that those preparations couldn't prevent the fear response? If some men broke under Stuka attacks and others didn't, was that because of differences in character and moral fiber, the traditional explanation, or was it because of differences in neurological vulnerability to acoustic stress, a mechanical explanation that stripped away moral judgment but also stripped away agency? The test pilots and engineers at Farnborough were discovering something that would take decades to fully understand, that courage and fear aren't purely matters of will, that human psychology has exploit points, that some weapons target the nervous system as precisely as explosives target structures. Allied doctrine began to shift based on these findings. Training programs started including acoustic stress conditioning, exposing troops to loud, startling sounds during exercises to build some tolerance. Tactical briefings began addressing the Stuka's psychological effect explicitly, naming it, describing it, trying to rob it of power through acknowledgement. Some units were trained to immediately begin firing when they heard the siren, giving soldiers a specific action to channel their fight or flight response into productive behavior. Air defense coordinators were instructed to prioritize Stukas even when other targets might be tactically more significant, because eliminating the siren's psychological effect was worth the tactical trade-off. These countermeasures helped, but they were reactive, defensive, treating the symptom because the underlying vulnerability, human neurology, couldn't be patched. There's a deeper irony here that the Allied analysts were beginning to recognize. The Germans had built the Stuka around a specific tactical doctrine. Close air support of advancing ground forces, destruction of specific tactical targets, integrated combined arms warfare. The aircraft's design reflected those requirements. Rugged construction for forward airfield operations, excellent low-speed handling for precision attacks, fixed landing gear that doubled as dive brake mounting points and, almost as an afterthought except it wasn't, sirens. Just sirens. Mechanically simple, aerodynamically neutral, acoustically devastating. The Germans had understood something that Allied air doctrine in the 1930s had largely missed, that the psychological impact of air attack could be as important as the physical destruction, that fear had tactical value, that you could break an army's will before you destroyed its capability. This wasn't unique to the Stuka. German tactical doctrine throughout the early war emphasized speed, violence, and psychological shock. The tank breakthroughs that shattered French defensive lines in 1940 succeeded not just through firepower, but through the speed and apparent unstoppability that paralyzed French decision-making. The paratrooper assaults that seized key objectives in Belgium and Crete succeeded partly through surprise and partly through the psychological effect of enemy soldiers appearing from the sky behind defensive lines. The Stuka was part of a broader approach that treated enemy morale as a target to be attacked as systematically as enemy formations. They'd industrialized psychological warfare, turned it from an accident of combat into a deliberate weapon system. The Allied response revealed something about different military cultures and assumptions. British and American air doctrine had emphasized strategic bombing, destruction of industrial capacity, attrition of enemy military power through material means. The idea of deliberately designing weapons primarily for psychological effect was almost alien. Not that the Allies ignored morale, but they treated it as a secondary effect of physical destruction, not a primary target. You bombed factories. The destruction damaged enemy war production. The damage reduced enemy capability. The reduced capability lowered enemy morale. The causal chain ran from physical to psychological. The Stuka reversed that chain. You screamed the sound damaged enemy morale. The damaged morale reduced enemy effectiveness. The reduced effectiveness made physical destruction easier. The psychological effect was the primary weapon. The bomb was almost secondary. Harper's final report, submitted in autumn 1943, after months of test flights and analysis, captured this shift in understanding. The document is remarkable for its honesty about the limits of rational countermeasures. He described the technical characteristics of the siren in precise engineering terms. He documented the acoustic frequencies, the volume ranges, the directional properties. He provided recommendations for tactical countermeasures and training modifications. But he also included a section that was unusual for a technical report, a section on the subjective experience of being targeted by a weapon designed to exploit your neurology. The difficulty, he wrote, is that understanding the mechanism doesn't disable it. Knowing that the Stuka Siren operates on automatic fear responses, knowing that the fear is disproportionate to actual danger, knowing that the aircraft itself is vulnerable and the attack is survivable, none of that knowledge prevents the fear response from occurring. Training can help soldiers function despite the fear. It cannot prevent the fear. This is not a moral failing. This is biology being weaponized. That last sentence represented a significant shift in how military psychology thought about combat stress. For generations, military culture had treated fear as a character issue, a failure of discipline, something weak men experienced and strong men overcame. The Stuka forced a different model. If a weapon could reliably trigger fear responses in experienced, disciplined, brave soldiers, if the response occurred regardless of training or willpower, then fear wasn't simply a moral choice. It was a physiological vulnerability that could be targeted. This didn't mean courage was meaningless. Harper's own experience showed that trained soldiers could function effectively, despite overwhelming fear. But it meant courage had to be redefined. It wasn't the absence of fear. It was the ability to function while your nervous system was screaming at you that you were about to die. By late 1943, the tactical situation had changed enough that the Stuka's psychological weapon was becoming less effective, not because the Allies had solved it, but because they'd eliminated the platform. Allied air superiority in North Africa, the Mediterranean, and increasingly over Western Europe meant Stukas couldn't operate without prohibitive losses. The Germans continued using them on the Eastern Front and in rear areas, but their days as a primary weapon system were over. The aircraft's vulnerability had caught up with its psychological effectiveness. Pilots might still fear the Siren, but they rarely had to face it because Allied fighters were shooting down Stukas faster than Germany could replace them. The solution to the psychological weapon was tactical: achieve air superiority, force the enemy to withdraw the platform, render the weapon system inoperable regardless of its psychological effect. But the questions the Stuka raised didn't disappear with the aircraft. Allied strategic bombing campaigns over Germany were producing their own psychological effects on civilian populations, effects that Allied planners were tracking and, in some cases, deliberately trying to maximize. The firebombing of Hamburg in 1943 created a firestorm that killed tens of thousands and psychologically devastated the survivors. Was that different in kind from the Stuka's Siren, or just different in scale? The atomic bombs dropped on Hiroshima and Nagasaki in 1945 would kill through blast and radiation, but also through something else, through the demonstration that a single aircraft could erase a city, through the psychological impact of a weapon so disproportionate to previous experience that it seemed to break the rules of reality. The mushroom cloud became as much a psychological weapon as a physical one, a symbol of overwhelming power that changed strategic calculations not through its actual use, but through the fear of its potential use. This is where the story opens into something larger than one obsolete dive bomber and its siren. What the Stuka revealed was that human psychology has exploit points, that the nervous system that evolved to keep our ancestors alive on the African savanna could be reverse-engineered and targeted. That fear isn't simply a failure of character, but a biological mechanism that can be triggered as reliably as any other reflex. This has implications that extend far beyond World War II. Modern military doctrine includes extensive psychological operations, systems designed to demoralize enemy forces, to shape civilian perception, to win conflicts by breaking will rather than destroying capability. Advertising operates on similar principles, finding the psychological triggers that override rational decision-making. Political propaganda targets the same fear centers the Stuka targeted, creating perceived threats that trigger stress responses, disproportionate to actual danger. The test pilots at Farnborough in 1943 were discovering something uncomfortable about human agency. We like to think we're rational actors, making conscious choices based on logical assessment of evidence and circumstances. The Stuka revealed how shallow that rationality is, how easily it can be overwhelmed by something as simple as the right sound at the right frequency. Harper could know intellectually that he was safe, that the dive was controlled, that no danger existed, and his body would respond as if death were imminent. Knowledge didn't protect him. Understanding the mechanism didn't disable it. The conscious, rational mind that thought it was in control was actually riding on top of much older, much faster, much more powerful systems that prioritized survival over accuracy, false positives over missed threats, immediate response over careful analysis. This creates a kind of vertigo when you think about it clearly. How much of what we call courage is actually just certain people having nervous systems that happen to be less responsive to particular triggers? How much of what we call cowardice is people having nervous systems that happen to be more sensitive? The traditional moral framework treats these as character differences, choices people make about how to respond to fear. The biological framework treats them as variations in neurology, differences in amygdala sensitivity and stress hormone regulation and sensory processing. Both frameworks can't be fully true simultaneously. If courage is primarily biological, then moral judgment of people who break under stress becomes complicated. If courage is primarily chosen, then the Stuka's effectiveness becomes inexplicable because trained soldiers should simply choose not to respond to the siren. The answer Harper's experience suggests is that both frameworks are partially true and both are inadequate. Fear responses are biological and largely automatic, triggered below the level of conscious choice. But what you do with those responses, how you function while experiencing them, whether you maintain discipline and execute your training, or whether you freeze or flee, that involves choice and will and character. Courage isn't not being afraid. Courage is being absolutely terrified and doing what needs to be done anyway. The Stuka's siren made everyone afraid. It was how soldiers responded to that fear, how they functioned despite it, that separated effective troops from broken ones. This doesn't eliminate moral categories, but it complicates them, adds nuance, requires acknowledging that people are facing different levels of internal struggle, even when external circumstances look similar. Allied troops who faced Stukas and held their positions weren't unafraid. They were functioning despite fear so intense that their bodies were preparing for immediate flight or fight. That's harder than it sounds. That's harder than facing a threat that produces a fear level your training and discipline can easily manage. Give credit where it's due. The soldiers who maintained fire discipline while the siren screamed, who executed tactical maneuvers while their nervous systems flooded them with stress hormones, who did their jobs while every instinct said to run, those soldiers were operating at the edge of what human neurology allows. The Stuka hadn't failed because Allied troops were braver. It failed because Allied troops learned to be brave enough despite the weapon being exactly as effective as designed. There's one more layer to examine, one more uncomfortable question the Stuka raises. If psychological weapons this effective exist, if you can design systems that target human neurology with precision, what's the ethical status of using them? The Stuka's siren didn't violate any laws of war. It wasn't a chemical weapon or a biological weapon or any category of explicitly prohibited weapon. It was just loud. But the intent was clearly to cause psychological harm, to break enemy morale, to create trauma that would persist beyond the tactical engagement. Is that ethically different from weapons that cause physical harm? Most people's intuition says yes, psychological weapons feel less legitimate somehow, but it's hard to articulate exactly why. Physical wounds can heal or not heal, but they're visible and measurable. Psychological wounds are invisible, sometimes permanent, sometimes more disabling than physical injuries. The soldiers evacuated from combat for psychological breakdown after repeated Stuka attacks, were they wounded? Military medicine in 1943 struggled with this question. Physical wounds got you a medal and medical care and respect. Psychological breakdown got you suspicion of cowardice, potential disciplinary action, stigma that could last a lifetime. The framework for understanding combat psychology was inadequate, built on outdated assumptions about willpower and character. It would take decades and multiple wars before PTSD was recognized as a legitimate injury rather than a moral failure. But the Stuka and weapons like it were causing those injuries systematically, targeting the nervous system as deliberately as artillery targeted trenches, creating psychological casualties as predictably as explosives created physical casualties. Harper continued flying test aircraft throughout the war, evaluating captured German equipment, providing technical analysis that informed Allied tactical doctrine. He never flew the Stuka again after the initial test program concluded. There was no need. They'd extracted all the useful data. But in interviews conducted years later, he always came back to the same point about that experience. "It changed how I thought about fear," he said. "I'd always believed courage was about control, about mastering your fear through discipline. The Stuka taught me that's wrong. You can't master that kind of fear. You can only function despite it. Real courage isn't the absence of fear. It's doing what needs to be done while you're absolutely terrified. That sounds like a cliché, but living it, feeling your body betray you while you force yourself to maintain control, that's different. That's harder than I can really explain." The final irony is that the Stuka's most lasting contribution to military history isn't what it destroyed. It's what it revealed about how future wars would be fought. The physical aircraft is obsolete, a museum piece, a relic of tactical doctrines that stopped working once the Allies achieved air superiority. But the principle the Stuka embodied, that you can win battles by breaking enemy psychology as efficiently as by destroying enemy capability, that principle is alive and evolving. Modern warfare includes sophisticated psychological operations, cyber attacks designed to create panic and confusion, information warfare that targets perception rather than physical infrastructure. The Stuka was crude by comparison, just a siren, but it was pioneering. It demonstrated that human neurology was a battlefield, that fear was a weapon, that you could engineer systems to exploit psychological vulnerabilities as precisely as you could engineer systems to exploit material vulnerabilities. Think about Harper in that cockpit, hand on the siren lever, about to voluntarily subject himself to something designed to break him, doing it because someone needed to understand the mechanism, needed to measure it, and analyze it, and find countermeasures. Think about the courage that required, not the physical courage of facing danger, but the psychological courage of facing a weapon that targeted his own nervous system. Think about him pulling that lever, knowing what would happen, feeling the fear response cascade through his body exactly as designed, maintaining control anyway, landing, filing his report, doing it again because the data mattered. That's not the kind of courage that gets written about much. It's not dramatic or heroic in the traditional sense, but it's courage nonetheless. It's the courage of facing what you fear most, not because you have to, but because understanding it matters, because someone needs to know, because if you don't measure it, you can't fight it. The Stuka dove out of history by 1944, withdrawn from frontline service, relegated to night harassment missions and rear area operations, finally grounded entirely as fuel, and pilots ran out. The siren fell silent. But what it taught echoed forward. It taught that fear is a weapon. It taught that psychology is a battlefield. It taught that courage isn't the absence of fear, but the capacity to function while afraid. It taught that understanding your enemy's weapons includes understanding what they're designed to do to your mind, not just your body. It taught that some weapons don't need to kill you to defeat you. They just need to break something inside you that's harder to repair than flesh and bone. When Harper climbed out of the Stuka after his first test flight, hands shaking, nervous system still flooded with stress hormones triggered by a siren attached to an aircraft in friendly airspace, with no actual danger anywhere nearby, he'd discovered something about human vulnerability that military doctrine spent the next decade integrating. We are not as rational as we think we are. We are not as much in control as we believe. We have exploit points, biological ones, that can be targeted and triggered as reliably as any mechanical system. Knowing this doesn't fully protect us. Understanding the mechanism doesn't disable it. But knowing helps. Understanding helps. Naming the thing helps, because you can't fight what you don't acknowledge exists. The Jericho trumpet's scream has been silent for 80 years, but listen carefully to modern warfare, to the psychological operations and information campaigns and perception management, and you can hear its descendant, evolved and sophisticated, still doing what the original did, finding the gap between who we think we are and how our nervous systems actually work, exploiting it, turning our own biology into a weapon pointed at ourselves. Harper measured it. Allied troops learned to function despite it. The war moved on, and the aircraft became history. But the principle remains still, will remain as long as warfare exists. The easiest way to defeat an enemy isn't always to destroy them. Sometimes it's just to make them afraid enough that they defeat themselves.